Bring it.
Okay, welcome to this talk. It's done by Dan Kawinski, who came here from Seattle. He's coming to CCC events for the last 4 years now, and this time we'll find very interesting stuff that he seemed to have found when he cleaned up his attic. I hope it will be very interesting and funny, and I'm convinced that it is, because I've seen some of the stuff at the camp on this summer. So, have a lot of fun.
Testing, testing. Do I actually have working sound here? Yes. Sweetness. All right, everyone. My name's Dan Kaminsky. I am incredibly happy to be back out here again for CCC. It is a long flight, but this is such one of my favorite cons every year. So thank you, everyone, for coming out. As some of you might know me, I do like the pretty pictures. These pretty pictures are actually audio visualization that has nothing at all to do with this talk. However, if you happen to be interested in audio visualization or know someone who is, please find me after, because I have things to ask you about. Like, what the hell am I supposed to be doing here? Because it ain't this. All right, so let's talk for a minute. Oh, by the way, that stuff I was showing, was anyone here at my talk last year where I was talking about dot plots? I kind of sort of ported all that to Winamp. And it works. I was really drunk when I started writing it. Especially when I'm like, this isn't supposed to work yet. Anyway, so what I'm here to talk about for this con actually is, well, for most of my talks, I do various stuff at various networking layers. This is the 7th time I've done a Black Ops, a TCP/IP talk. I really should come up with a new name. But I like it. I don't know what to say about that. I've talked about lots of different things. SSH and high-speed network scanning and DNS and more DNS and more DNS, yes, this is true. Some pattern analysis stuff. Been playing a little bit with network neutrality research. I finally decided after all these years, all right, it's time I finally mess with the web. What finally got me to look at it? Oh dear God, it's huge. There is so much crap in web browsers. I had no idea. It's beautiful. And wait. Apple people, I'm not being light on you. The best part is I was totally going to Photoshop that to look like the iPhone, and then I'm looking at the frame, I'm like, I don't need to do anything. So the web really is where the wild things are nowadays. You know, the amount of websites out there with cross-site scripting is just absurd. It's, you know, you hear numbers up to like 70 to 80%, and honestly, it's probably an underestimation. The web's turned into a way to distribute worms nowadays. There was a malicious WMF file that was put on the website of the Super Bowl. It actually infected, I think it was 3 or 4 million people. We haven't seen 3 to 4 million infection rates in several years. It's back. Ad networks are getting hit like nothing has been hit in a long, long time. But what really got me to start looking at the web was this thing called the DNS rebinding test by a guy named Dan Benet over at Stanford. What Dan went ahead and did was he was playing around with Flash, he and his team, and they put a Flash applet on an ad network. And overnight, for $50, they got into 100,000 networks. 50. Yeah. So there are a few key words here. We had DNS, we had tunneling, we had behind firewalls. All right, I got to get me some of this. This is such my domain. So I'm like, okay, let's see what is going on here and see if there's any kind of interesting stuff that I can take a look at. It turns out DNS rebinding is an old bug, like 1996 old. Like, so old, they forgot about the bug and put it back. Oh. A ton of people have actually been going into this. I'm not the only one. Benet at Stanford's been driving the most thorough research, been writing the papers. But the attack dates back to 1996. I mean, we call it the Princeton attack because we have no idea who those undergrads were who found it. The guy who set back off the research of this was Martin Johns, who's somewhere around here. He revived the attack in August 2006. And Arsnake of the Hackers.org blog also has been driving a lot of interest in its general direction. DNS rebinding, small little DNS bug, totally breaks the security model of the web. What do I mean by that? Well, kind of an introduction to the way that the web works. Web pages, they're not unitary things. They're not like an atomic, I have the web page, it is one file. No. Web pages are pretty much pulled together at the time they are loaded. You might have your page from here, and your ads from there, and your images from here, and your music from there. They're pulled together. Average websites on like 10 different servers. On the web, you can even have an entire second web page and another web browser inside your main browser. This is called an iframe, an internal frame. This embedding facility, if you think about it for just a moment, this could be really dangerous. What if you go to some random website and there's Hotmail in there? They embed Hotmail. And what if you were already logged into Hotmail? This iframe, it's another web browser, but it's on someone's page. Could they use JavaScript? Could they go inside? Could they script your Hotmail? Could they read your messages? Could they impersonate you? Could they basically be you just because they put Hotmail inside, www.attacker.com? Well, it turns out they thought of this, and they created a policy. They call it the same origin policy. You all can think of it as look, but don't touch. The idea is that you can go ahead and you can embed other people's resources. You can even embed other people's websites. And you can show it to the user. And the user can click and do everything normally from the user perspective. But from script, from JavaScript, no. You can show it to the user, but you don't get to look inside, poke inside, read their mail, write the mail. The user can do what they want. The user can do things, but the software outside, the surrounding page, it is limited. That is the security model. And the idea is that foo.com can look inside foo.com's resources, but can't look inside bar.com's. So if you go to like an attacker's website and they embed Hotmail, well, can't look inside, sorry. The security policy seems so very logical. If two things come from the same place, well, they must be trusted the same. All right. Well, the same place should be the same name, right? Right? No. Names don't actually host anything on the internet. Everything comes from IP addresses. Now, we use DNS, my favorite protocol of all time, to translate between a name we trust and the IP address we're actually going to communicate with. And you might say, well, foo.com's over at 1234. Bar.com's over at 3456, and never the twain shall switch or change, or no. Bar.com can return whatever the hell it feels like. So, you can go over to bar.com, and it can return its own IP addresses, or it could return somebody else's. DNS makes no guarantees about the ownership of IP addresses. So let's think about what that actually means. So at one point, bar.com can refer to some server, out here, this is really an Americentric slide now that I think of it. That faraway mystical land of Europe. S, Europe, China, G. Okay. So, one moment bar.com points at a server in. There you go. You guys are awesome. The next moment, no, that's the printer down the hall, out here in Europe. Now, suppose for a moment your browser loads a page from out in China, and some research from the page out in China says, hey, I need to get something else. Only now it doesn't come from out in China. Now it comes from your printer. It's an iframe of the printer. Well, now script from China is able to script against the printer and is able to drive it as if it was local. Now, IP was built to think, we have a global address space, there are no firewalls, if I can reach it, you can reach it, everyone can reach it, it's a big party of reachability. Yeah, that's not the real world. Real world is totally about islands of connectivity with very well-defined interfaces. Unfortunately, these bugs involve, I may not be able to reach your printer, but you can, and I'm going to bounce off of you to get to these internal resources that I don't normally have access to. So why does this work? What is going on here? This seems like a pretty obvious bug. Well, the deal is that the browser has no idea that bar.com from an external IP out in China is any different than bar.com from an internal IP printer down the hall. This is by design. Design bugs, a little bit of an offshoot, design bugs are the best bugs ever. No one ever takes a dependency on a buffer overflow. No one's like, man, this code really needs to crash or we're screwed. People take dependencies on design bugs all the time. If you look at Google, if you look at actually any major website and you do DNS lookups on them, you will often see that you get back a whole list of IP addresses, any of which will theoretically provide Google's content. And this is by design, this is necessary. You need what's called DNS failover. If one IP fails, try the next. Nowhere does it say that these other IPs that you try are actually going to be Google. Thus the bug. Google can return whatever IP they want. Bad guy can return whatever IP they want, and you, the browser, have to accept it, because it might be real. And you don't want errors, scripting error, Google has a new IP. Google has 10,000 IPs. Yes, they have a new IP. So, yes, the very easy ways of detecting that a script has gone from one IP to the next. What the hell do you do about it then? Therein lies the problem. So let's talk about the canonical attacks here. Canonical attack is actually firewall bypass. Most corporate networks draw a significant distinction between the external network full of bad guys and the internal network that is, of course, totally safe. Of course. Hey, we deal in optimizations. The very, very simple firewall rule set, things on the inside can go out wherever they want, but if you're on the outside, you're just not coming in. Well, by bouncing off a lured web browser, an attacker on the outside can reach resources on the inside. Levels of exploitation. Let's talk about what it means to actually reach inside. Well, the basic level of exploitation is there are no plugins involved. You just use the web browser. One iframe's out in China, the other's in the printer down the hall, and the two iframes are able to script against each other because they're both badguy.com. There's no plugins, there's no magic. You just use the browser as it is. Oh dear God, this is going to be miserable to fix. It wins you arbitrary HTTP sites. Level 2 actually starts getting into some of the plugins that are available. MSXML, XML HTTP requests, Silverlight. These things actually give you a little bit more control at the HTTP layer. You start being able to add a few headers. You start being able to interact with web services. For those of you who might actually be working inside of some companies, you might see, wow, instead of RPC, we're moving everything to XML because XML is magically awesome. It must be safe. It has angle brackets. Please stop writing crappy XML parsers. Please, please, please. Web plugins are awesome and cool and will break all sorts of things, but no. Forget restrictions. Let's just play with the real stuff. We have plugins in 90% of browsers that just give us raw sockets. Java will actually give us both TCP and UDP. Flash, which is even more well deployed, gives us TCP sockets. Now we're not restricted to things on the web. You can talk to database servers, you can talk RDP, you can talk